Hey everybody, we are back and we're talking about functions in section 2, so let's jump in. So in section 2, we're talking about what is a function, and it's usually denoted by like a little curvy f, and the definition is to go from a set, we'll call it A, so from the first set to another set of numbers B, we'll call it B, and it's a relation that assigns each element from set A to one element in set B. Okay? What is the domain? So the domain, if you remember that term, is the set of inputs of function f. And the range is the set of outputs of function f. The independent variable is the variable that is the input. And the dependent variable is the output variable. So I want you to think of a function like this. So if we call this set A, that it's some set of numbers, okay? And then it goes into our function box, where this is kind of like a machine and it turns something out. So the function does something and it equals the set B. Then it takes the number x, puts it into the function machine, and it comes out a transformed something from the function. So if we're talking about an introduction of functions, a correspondence that matches quantities or numbers from one set with items to the different set, and we call that a relation. Okay? So it relates one set of numbers to another set of numbers. The functions that can be represented by ordered pairs, the first coordinate in each ordered pair is the input. So kind of like if you've got an ordered pair x comma y, the x's are the input, and the second coordinate is the output. So in this ordered pair x comma y, x is the input, y is the output. So here's some characteristics of a function from set A to B. The first one is that each element of set A is matched with an element from set B. 2. So the second characteristic is that some elements of B may not be matched with any element of A. And then characteristic 3 is that two or more elements from set A may be matched with the same element of B. All that means is that your second element or your y can be repeated. And then lastly, an element of A, or the domain, cannot be matched with two different elements of B. What that means is that the sets from A, or the x coordinates, cannot be repeated. Okay, that's lots of writing. So to determine whether or not a relation is a function, basically you're going to look to see if the numbers in the first set has any repeating values. Often it means you're going to look to see if x is repeated or not. If it's repeated, it's not a relation or it's not a function. Okay, if any input value is a relation is matched with 2 or more output values, then the relation is not a function. Okay, so we can represent them verbally in a sentence. We can just say, like, for example, the function is 3 times x. It can be numerically, like a table, x, y, 1, 2, 3, 4, 5, 6, whatever, or as a set of ordered pairs. You can also have it graphically, like points on a graph. And lastly, you can have it algebraically, like an equation in 2 variables, like y equals 2x plus 1. So if I can see all those different types of functions can be written, let's look to see at this example of this table if it is a function. So again, remember how to look for a function? We said before, look at the values of the x. Are these repeating any values? Here, I don't see any repeating values, so we say yes. Y is a function of x because x doesn't repeat. All right, so let's talk about function notation. The symbol f of x is function notation. The symbol f of x corresponds to the y value for any given x. Keep in mind that f is the name of the function where f of x is the output value. So for example, if f of x equals x squared, f when x is 1 would be 1 squared, which is 1. So when x is 1, then f of x is the other value. Okay, so x is the input, f of x is the output. In function notation, the input is the independent variable, and the output is the dependent variable. Okay, so if we were to do this, if this is the function, how would we find f of negative 2? You've probably done this before. All we have to do is replace every time I see w with the value of negative 2. Okay? Let's talk about a piecewise function. As the name says, it's a function in pieces. So it's a function that is defined by 2 or more functions over a specific or specified domain. And then let's talk about the domain of a function. The implied domain of the function is the set of numbers, the expression is defined. So basically, we say, okay, this works for these values of x. That's the implied domain. So here's in general what the domain of a function will exclude. Any time that you would cause a division by 0, right, which would be an undefined value. So we want to exclude those values, or a root of a negative number. Because remember, a root of a negative is an imaginary number. So we don't want to include numbers in the domain if it makes it undefined or imaginary. So no values that would make it undefined or imaginary. All right, that's it for today. We'll come back and talk about this and do practice on Monday. See you later.